misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Sirih berlipat, sirih pinang, sirih berasal dari Pulau Mutiara. Pemanis kalam, selamat datang. Awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat datang ke kelas tuition online percuma bagi subjek fizik SPM tingkatan 5 yang dibawakan khas untuk anda oleh Akademi YouTuber Malaysia dengan kerjasama e-Didik Malaysia dan Kelab Guru Malaysia. Apa khabar semua penonton yang sedang menyaksikan siaran langsung ini? Saya harap di mana jua anda berada, anda sentiasa berada dalam keadaan yang sihat walafiat. Okey, baiklah guru-guru dan para pelajar yang cikgu kasihi sekalian, untuk memulakan kelas kita pada malam ini, ayo kita buka dengan Ummul Kitab Al-Fatihah. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. InsyaAllah mudah-mudahan kelas kita pada malam ini mendapat rahmat dan berkat daripada ilahi. Jadi pelajar-pelajar yang bersama dengan cikgu pada malam ini, anda boleh tuliskan di ruangan sembang. Hai, selamat datang semua. Boleh perkenalkan diri anda dari sekolah mana dan siapa nama. Okey. Jadi pada malam ini cikgu bersendirian saja di konti secara all in one. Cikgu perkenalkan diri terlebih dahulu. Saya Cikgu Hasnitah binti Andy Mario, kini berkhidmat di SMK Bagan Jaya Batawa Pulau Pinang. So, apakah tajuk yang akan cikgu kongsikan pada malam ini? Anda boleh tengok seperti pada kelihatan di bawah. Kelas fizik pada malam ini akan membawakan tajuk 2.3 gas pressure. Ini adalah kelas untuk DLP. Okey, jadi anda boleh sharekan dulu link kelas ini kepada kawan-kawan yang lain. Mudah-mudahan lebih ramai lagi dapat manfaatkan kelas kita pada malam ini yang akan bersiaran secara langsung lebih kurang 1 jam. Okey, dan untuk makluman semua, saya akan kongsikan link isi jil kelas malam ini di akhir sesi nanti. Anda boleh isikan dalam tempoh 30 minit selepas cikgu tamatkan siaran live ini, dan boleh isi menggunakan sebarang domain email, tapi pastikan anda isi dengan maklumat yang tepat supaya sijil dapat dihantar ke alamat email yang betul. Okey. Jadi untuk tidak membuang masa lagi, cikgu mulakan kelas pada malam ini dengan menunjukkan dahulu ini adalah kelas fizik SPM yang berlangsung pada minggu ini. Pada Jumaat lepas telah disampaikan oleh Cikgu Rosmawati, kelas fizik tingkatan 4 dengan tajuknya 2.4 inertia. Jadi siapa yang tertinggal kelas ni jangan risau, anda boleh tonton semula di channel Cikgu Rosmawati pada bila-bila masa anda lapang. Okey. Dan pada malam ini cikgu akan teruskan dengan 2.3 pressure, 2.3 pressure. Alright. Okey. So ini adalah ahli panitia fizik di Akademi YouTuber yang telah banyak membantu saya untuk menerbitkan video-video PDPC, sama ada untuk kelas DLP ataupun bukan kelas DLP, walaupun ada di antara guru-guru ini yang tidak lagi bersama-sama dengan kita. Tetapi cikgu harap anda dapat manfaatkan semua video-video yang telah dihasilkan oleh guru-guru berkenaan. Di mana boleh dapatkan videonya? Mudah sahaja. Anda boleh muat turun apps yang diberi nama Akademi YouTuber di Android anda. Ringan saja appsnya dan dia tidak akan membebankan memory phone anda. So download turun, muat turun apps ini, Akademi YouTuber. So di dalamnya kita ada himpunan lebih 25,000 video PDPC untuk pelbagai subjek daripada peringkat prasekolah hinggalah ke pra universiti. Jadi manfaatkan sebaiknya video-video yang telah dihasilkan oleh guru-guru sukarelawan Akademi YouTuber dari serata Malaysia ini. Alright, okey, jadi Sebelum cikgu bermula, cikgu nak maklumkan nota PDF pada malam ini anda boleh dapatkan pada pin message, boleh di-download dan cetak keluar secara percuma saja dan anda boleh gunakan modul ini bersama-sama dengan video kelas pada malam ini. Okay, kelas malam ini juga anda boleh tonton pada bila-bila masa mengikut kelapangan anda. Alright, jadi cikgu harap video dan nota ini membantu anda memahami tajuk ini dengan lebih baik. Okay, jadi cikgu harap semua sudah bersedia ya. Okay. So students, if you are ready and good to go, let us proceed with our lesson tonight with 2.3 gas pressure. Okay, for your information, this topic is covered in your textbook from page 56. It's a simple one. So what is the learning standard for this topic? Okay, there are two learning standards which you must master very well. The first one is 2.3.1 is to determine gas pressure by using a device which is called as manometer. Okay, and then second is to solve problem in daily life involving gas pressure. Okay, students, so if you look at this GIF, okay, the moving graphic there, the red dot is actually represent gas particles. Okay, gas particles. So these gas particles contain in you look at this GIF, it will give you the definition for gas pressure. How does gas pressure produce? Okay, so from this GIF, okay, gas pressure is exerted due to the collision of the gas particle and the inner wall of the container. So if you look at this gas particle, they are moving in random. So when they move randomly, they will collide among themselves and they will collide with the inner wall of the container. So the collision between the gas particle and the inner wall of the container is the causes for the production of gas pressure. So what is gas pressure again? It is the pressure exerted due to collision of gas particle and the inner wall of the container. All right. Okay, next. Okay, so this is our first learning standard, how to determine or how to measure gas pressure by using manometer. So what is manometer, students? If you look at this diagram, this U-shaped tube is what we call as a manometer. So manometer consists of a U-tube that is filled with liquid. It can be water, it can be oil, or it can be mercury, which is used to measure gas pressure. Okay, which means if you want to use this manometer, you must connect one of its end to a gas sources. Okay, and the other end is exposed to the atmosphere. All right. So if you look at this figure, this is a situation before this manometer is connecting to any gas supply. So you can see that level of water in both arms are equal. Okay, on the left and on the right side. So if you look at the question here in figure A, what happened to both water level when both end of the tube is exposed to the atmospheric pressure? So you can see both end are an open end and it is now exposed to atmospheric pressure. So what happened to the water level? As you can see, obviously, at this situation, both water level on the left side and on the right side are the same. But the exercise sheet I provide for you in this link. All right. Okay. Then next. Okay. So now this is the situation when we connect one end of the manometer to a gas tank. All right. And the other one is leave or exposed to the atmosphere. So now you can see that when this valve is open, okay, when the valve of the gas tank is open, you can see now there is a difference between the water level inside the U-tube in both sides. All right. So in the second question in diagram B, what happened to the water level when one end of the tube is connected to the gas supply? So how to respond to this question? So according to the diagram, you can answer it this way. Okay, the high gas pressure will push the water at this side downwards. So this will cause a difference in the water level now at both ends. Okay, and students, if you notice in this diagram, the difference on the water level is marked as H. Okay, the difference in the water level at this end and at this end is represented by H. Okay, so what is H in the third question? H represent the difference between the gas pressure and the atmospheric pressure. Okay, so the difference in water level is actually represent the difference between the gas pressure and atmospheric pressure. So atmospheric pressure acting on the open end, while gas pressure acting on this side, which is connected to a gas supply. So I hope you are clear until this point. Okay, then we proceed with question 4. Okay, the question asks you, what is the pressure at A? Okay, so what is the pressure at A? Pressure at A is equal to gas pressure. So we will calculate them later on. So pressure at A is gas pressure. Okay, and then what is the total pressure at B? Okay, point B is point which is level with point A at the other side. So how to find total pressure at B? So if you understand, at point B, there are two pressure acting on this point. The first point is the first pressure is atmospheric pressure on top, and second is the pressure due to liquid in this column. Okay, P water if it is a water. So the total pressure in B is atmospheric pressure plus liquid pressure, which is water pressure. All right. Okay, then 6, we are asked to compare pressure at B and gas pressure. So, what do you think? Are they different or are they the same? And give one reason for your answer. Okay, students, for this one, since they are in the same level, so we understand pressure at B is equal to pressure at A, which is also the gas pressure. All right. And then number 7, write one equation which relates atmospheric pressure, gas pressure, and water pressure. So how we combine all these three pressure in one equation. Okay. So this is the reason why PB equal to P gas, pressure at B equal to pressure gas, because they are at the same level. Okay, so this is the equation which relates gas pressure, atmospheric pressure, and water pressure. Gas pressure is equal to atmospheric pressure plus water pressure. All right. Okay. Okay, now let us check these three different situations. Okay, you are given 3 figure A in number 8, figure A, figure B, and figure C. Okay, what do we have in figure A? If you look, the right end of the U-tube is connected to a gas tank, and the left side is exposed to the atmosphere. Okay, so the green arrow represent the gas pressure, and the red arrow represent the atmospheric pressure. Okay, so students here, since if you look, when we open the gas tank, for this case, okay, you can see the water level at both arms are the same. So we understand in this situation in figure A, gas pressure is equal to atmospheric pressure. Okay, and here in figure B, okay, now you can see that the right side is connected to a gas tank has a lower liquid level compared to the left side, which is exposed to the atmosphere. Okay, so what do we understand here? We understand that gas pressure is higher than atmospheric pressure, so it will push the liquid at the lower level, okay, on this side. So how to write the equation or the relationship between all the pressure here? So gas pressure here, how to determine gas pressure? So gas pressure is equal to atmospheric pressure, the red arrow, plus the water pressure, represented by the blue arrow. So if they give us the value, so we can calculate gas pressure. Okay. And here we understand gas pressure is greater than atmospheric pressure. Okay. And in the third situation in figure C, you can see now the water level that connected to a gas supply is higher compared to the water level exposed to the atmosphere. So what do we understand from this figure? Yes, very good. We understand that atmospheric pressure is greater compared to gas pressure. So it will push the liquid on this side at the lower level. So how to write? How to find the gas pressure in case C? By subtracting the atmospheric pressure to the water pressure. So P gas equal to P ATM, atmospheric pressure, minus H. Okay, remember what is H just now? The difference of height, which is represent the difference in pressure. Okay, so here in figure C, we understand gas pressure is lower than atmospheric pressure. All right. Okay. So that is the first learning standard to understand gas pressure and how we relate gas pressure, atmospheric pressure, and the pressure difference by writing a formula relates all three. Okay, and students, the formula that we write in the first part, we will use them in the second learning standard. Okay, so now let us begin on the second learning standard, how to solve problem in daily life involving gas pressure. So we begin with question 1. Actually, you can find this question in your textbook as well when you check on figure 2.19. So we have a manometer here, a U-tube, which is connected to a gas tank on this side. And you can see the pressure difference or the level of the water difference. Water level is centimeter, okay, stated in this figure. So this is the information you are given. Figure 2.9 shows the mercury manometer connected to a flask with compressed gas. We use mercury as the liquid here. All right. Given the atmospheric pressure is 76 centimeter mercury and density of mercury is given 13,600 kilometer per cubic meter and gravitational acceleration is given as 9.81 meter per second squared. So the first question, what is the pressure of the compressed gas in centimeter mercury? Okay, so if you look at this figure, which case can we relate to the previous slide? Situation A, situation B, or situation C? So from the figure, we understand since the mercury pressure is higher than atmospheric pressure for this case. Okay, so by that, okay, we use this formula. P gas is equal to P ATM plus H. Okay, they want you to write the answer in centimeter mercury. Okay, so this is atmospheric pressure in centimeter mercury, 76. And this is the mercury pressure, okay, or the mercury height, 40 centimeter mean 40 centimeter mercury. So we just plus them. So it will give you 116 centimeter mercury. This is the gas pressure. Okay, and then B, they ask you to calculate the gas pressure in Pascal. So in case B, you have to convert 116 centimeter mercury into Pascal. So how to convert centimeter mercury into Pascal? Okay, so this is the formula we are using, okay, in order to determine the gas pressure in Pascal. Okay, P gas equal to H rho G. Okay, H rho G. H refer to this, okay, 116 centimeter. But to apply this equation, it must be in meter. So 116 convert into meter will give you 1.16, okay, meter. And this is the density of the mercury given in the information. And this is G, gravitational acceleration. So when you solve, you will find the answer is 154,762.56 Pascal. So this is how we calculate the pressure in Pascal. All right. And then in C, students, will your answer in A and B change if the glass tube of the manometer has a larger diameter. So they ask if we change this manometer to a bigger size, will it affect the pressure? So the answer is no. Okay. So this is the answer in scientific notation 1.5476 times 10⁵ Pascal. All right. So the answer, no change, because pressure in liquid does not depend on the diameter or size of container. So if you remember, what factor affect pressure in liquid? Yeah, the density, the depth, and gravitational acceleration. Nothing to do with the size or diameter of the container. All right. Okay, that goes for question 1. Okay, now let us go to the second question. Okay, this one also you can find in your textbook. Okay, figure 2.2, student. It shows the mercury manometer used to measure the pressure in a flow pipe. Okay, so this is the diagram. You can see the air flow in this direction from the left to the right. The valve here is now open, so the air will went into this opening. Okay, and this is the manometer. Given the difference in height is 25. So 25 is H, 25 centimeter. So the first question, what is the difference between the air pressure in the pipe and the atmospheric pressure in centimeter mercury? Okay, so for this question, nothing to calculate because it is seen obviously from the diagram. So the difference is 25 centimeter mercury. Okay, 25 centimeter mercury. Okay, then question B, given the atmospheric pressure is 75 centimeter mercury, so what is the air pressure in the pipe in Pascal? So they ask you to find in Pascal. Remember, in the first question, what is the formula we use to calculate pressure in Pascal? Yeah, very good. It is P equal H rho G. So we use that formula. Okay. So before that, this is the pressure in centimeter mercury. Okay, the pressure in centimeter mercury is 100 centimeter mercury. Okay, so to apply this pressure, 100 convert into meter, so it will be 1. Okay, 1 meter mercury. So this is the density, and this is G, gravitational acceleration. So by that, the answer is 133,416 Pascal. Okay, easy, right? Okay. Okay, so that is for the first part. So what if we take a short break before we come back with more example of SPM format paper, especially in paper 2. So don't go away. I'll be right back after this short commercial break. Okay, students, welcome back to the lesson. And for those who are just joining us, welcome to Kelas Tuition Online Percuma brought to you by Academy YouTuber with the collaboration from Idiot Malaysia and Kelab Guru Malaysia. And now we are entering the second part where SPM practice paper, especially on paper 2. Okay, for your information, I have shared the module for this class in the pin messages. You can download and print them out all for free. All right. Okay, students, if you are good and ready to go, let us discuss with the first question. This is the question on paper 2, which is in part A. Okay. So question number 1, you are given diagram 1.1. It shows a manometer which is used to measure the gas pressure in the gas container. All right. Okay, so you can see this is the gas container connected to the U-tube. So this part is labeled as X and the part at this end labeled as Y. And the difference of height between the two level of mercury is given 60 centimeter. Okay, so first question, state one reason why mercury is used in the manometer. So instead of water, oil or any other liquid, what do you think of the advantages of using mercury in manometer? Okay, you can share your answer in the live chat as well. So the answer is why we are using mercury. So this is the advantages or the characteristic of mercury, which makes it a better choice for to be used in a manometer. So first, it has a high density. Second, it has opaque color. Opaque color, so easy for us to read. Okay, easy to be seen. And also, it is not stick to the glass wall. Mercury does not stick to the glass wall. So you can write any of these three reasons. All right. Okay. And for question B, students, they ask you to mark with the symbol PG representing gas pressure and PATM representing atmospheric pressure in the boxes X and Y to show atmospheric pressure and gas pressure. So where to put PX? Where to put PG? Where to put PATM? So we have two boxes there, X and Y. So student, yes, we write PG inside box X and we write PATM inside box Y. Okay. Okay, very simple. Okay, then second question, B2. Now we have to calculate the gas pressure in diagram 1.1. So what will be the gas pressure? Here you are given atmospheric pressure 76 centimeter mercury. Okay, for this question, they didn't ask you to put in either in centimeter mercury or in unit Pascal. So you can write the answer in one unit, okay, either in centimeter mercury or in Pascal as well. Okay, so this is the answer in centimeter mercury. So atmospheric pressure, gas pressure. So from this figure, we understand gas pressure is greater compared to atmospheric pressure. So how to find gas pressure? By adding atmospheric pressure and H, the pressure difference. So 76 plus 60. So we'll give 136 centimeter mercury. So this is the answer in centimeter mercury. Okay. And if you want to write the pressure in Pascal, you do as the previous question. Use the formula P gas equal to rho Hg. All right. Okay. Then this is question C. You are given diagram 1.3. It shows a 3 sphygmomanometer. Okay. P, Q, and R, which is used to measure blood pressure of a patient. So this is the device we are using to measure blood pressure of a patient, sphygmomanometer. And it is work based on the principle of atmospheric pressure. Okay, student. So this is design P. Okay, if I zoom it for you, if you look at design P, so this is the sphygmomanometer. It has inflatable curve and the material is made from nylon. Okay, it has inelastic pumping bulb. Okay, and this is the manometer using mercury. Okay, that is the specification for sphygmomanometer P. And then what about sphygmomanometer Q? So this is the design. You can see it is also used nylon as the material for the inflatable curve, but here it is using elastic pumping bulb. Okay, and it has a release valve screw here, manometer containing mercury. Okay, and for design R, this is the sphygmomanometer R. The inflatable curve is made from cotton. The material is cotton. It has elastic pumping bulb and also has a release screw valve. Okay, release valve screw, and the manometer is containing mercury. So, if you study this tree diagram, there is a part which is similar and there is a part which is different from one and another. So which one is a better choice for us to be used in order to determine the blood pressure of a patient? So this is what we are going to answer in the next question. Okay. First, based on diagram 1.2, you have to state the characteristic of the sphygmomanometer, which can be used to measure the blood pressure efficiently. All right. So this is you have to give your reason according to the suitable characteristics. So first, the pumping bulb. So we have two types there, elastic or inelastic. So which one do you think is a better choice? So we choose elastic pumping bulb. Okay, elastic pumping bulb. Why? Because it is easy to pump, or you can pump continuously. So when we pump, okay, when we release the pump, since it is elastic, so it will return back to its original shape and size. Then we can pump again and again. So we can pump continuously. All right. And then the material used for the inflatable curve. So you have two choices there. Is it nylon or cotton? So which one do you think is a better choice? So we choose nylon instead of cotton. Why choose nylon, students? Because nylon is stronger compared to cotton, and it can withstand high pressure. It is long lasting, easy to wash, and also not easily tear compared to cotton material. Okay, then. So with these two characteristics, which one do you think is a better choice? Using elastic pump bulb and using nylon as a material for the inflatable curve? So definitely, obviously, the answer is sphygmomanometer Q. So we write Q as our choice. So this is the format of answering this question, where you can find in question 8 and question 7 in section A. All right. Okay, next. Okay, now let us try to answer one question in section B. Okay, so first you are given diagram 1.1. It shows a U-tube which is connected to a gas cylinder. So we are using mercury inside the tube. All right. Okay, first name the measuring instrument of gas pressure shown in diagram. So what instrument we are using to measure gas pressure? Students, so what? Answer is manometer. So we are using manometer to measure gas pressure. All right. Okay, then find the value of D in a unit of centimeter mercury. So D, this is D. So D is actually normally represented by H. But here is represented by D. The difference in the mercury level between the left side and the right side, which is exposed to the atmosphere. So how to find? So if you look, this is the height given from this end to the bottom of the U-tube. Okay, and this is the which is 14 centimeter. And at this left side, we have 6 centimeter. This is the height of the mercury level connected to the gas supply to the bottom. So how to find D? So you just minus. Okay, to find D, 14 centimeter minus 6 centimeter. So it will give us 8 centimeter mercury. Okay, so what is this 8 centimeter mercury? Yeah, this is the pressure difference between the gas pressure and atmospheric pressure, right? Okay, then the next question. find or calculate the total gas pressure in a unit of centimeter mercury. So how to find the gas pressure. So from the diagram just now, we understand gas pressure is greater compared to atmospheric pressure. So how to find gas pressure? So gas pressure is atmospheric pressure plus D. Okay, the difference in height. So 76 is the atmospheric pressure and 8 is the answer we calculated earlier. So the answer is 84 centimeter mercury. Okay, 84 centimeter mercury. Okay, and then question 3, you have to calculate the total pressure of the gas in a unit of Pascal. Okay, again student, how to find the gas pressure in a unit of Pascal. So we are using this formula. Okay, pressure gas equal to H rho G. H is the height is 184 centimeter. Convert into meter will be 0.84. Alright. And this is the density of mercury, 13,600 kilogram per cubic meter. And this is gravitational acceleration, 9.81 meter per second squared. Okay, so the answer is 112,069.44 Pascal, or you can also write in standard notation 1.12 times 10 power of 5 Pascal. Okay, easy, right? Okay, then, okay, question 4 is K-BAT, hot question. Okay, they ask you, what happen if there is a hole on the cylinder? Okay, now there's a hole on the cylinder. So the gas will start to leak from this hole. So what will happen to the difference of the level of mercury D? So what happened? So when some of the gases are leak to the surrounding, so you will see the level of difference will be decreases. So the value of D will be decreases. Okay, means the gas pressure decreases. Okay. Okay, now let's check for a short essay question here, which represent 4 marks. Okay, 4 marks. So you are given diagram 1.2. It shows a kid who use straw to drink from the glass. Okay, so they ask you to explain the working principle of the straw. Right? Okay. So how the kid can take the water out from the glass by using a straw. So how to get 4 marks. Okay, students, so we write our point one by one. So first you can write when the kid suck the drink through straw, air inside the straw is sucked out. Okay, so second, what happened? This will create a partial vacuum inside the straw. So when the air from the straw is sucked out due to the action, so it will create partial vacuum condition inside the straw. Mean it will create low pressure inside the straw. So this will cause a difference in pressure. Okay, atmospheric pressure outside is higher compared to the pressure inside the straw. So what will happen? The air will push. Okay, force is used to push the water into the straw. Remember, when there is a pressure difference, it will causes a resultant force to act, which will push the water entering the straw. So by that, the kid can drink through the straw. So this is the first point, second point, third point, and fourth point, which represent 4 marks. All right. Okay. Okay, then we go to the long essay question now, which represent or allocate 10 marks. Okay. So how to get these 10 marks? Actually, very easy if you understand the format of writing. So it is all to do with the knowledge of this content. All right. So in diagram 1.3, you are given a vacuum cleaner, student. Vacuum cleaner. Okay. So we are given B, C, and D. All right. Okay. And this is the 4 characteristic of each of the vacuum cleaner. the diameter of the handle rod. A and D has a bigger diameter of handle rod. B and C has a small diameter of handle rod. And then this is the material used to make the hose. Okay, A and C is made from aluminium. Okay, the hose is made from aluminium, while B and D is made of plastic. The hose. All right. And then the size of the fan, you can see the fan is inside the vacuum cleaner. A and C has a small size of fan. Okay. B and D has a bigger size of fan. Okay. Then this is the power of the motor. Okay. A and C has a low power motor, 600, while B and C has a high power motor, which is 1500, 1500 watt. Okay, so all these characteristics, you have to choose which vacuum cleaner is the most efficient to be used by the housewife to clean his house. Okay, so how to answer this kind of question? So you are very highly recommended to place your answer or to write your answer in a form of table. Okay, and then student, the table consists of 2 columns is enough. Okay, 2 column. So we write the characteristic on the first column and reason or explanation on the second column. And you have to write back all the 4 characteristics given. Okay, just write back. Okay, thank you very much, Mr. Pei, for joining us tonight. Okay, for joining me tonight. Okay, so the first characteristic, the diameter of the handle rod. Okay, so diameter, we have 2, big or small. So which one is a better choice? Yeah, we choose a small diameter of handle rod. Why choose small? So that dusty air can move into the vacuum with high velocity. So when the area is small, the dusty air can come into the vacuum at high velocity. Okay, and then material used to make the hose. So just now we have 2 material, either aluminium or plastic. So which one is a better choice? So definitely we choose plastic. I never saw a hose which is made from aluminium yet. Okay, then easy to bend or flexible. Can you imagine if the hose is made from aluminium? It will be hard to bend then. So it will make the household struggle to clean the house. Okay, size of the fan, big or small. So choose one. So it is better to be big. Why? So it sucks more dust into the vacuum cleaner. All right. And the power of motor, of course, it has to be high power so that the fan can rotate faster. So mean it can suck more dust into. Okay. Okay, then from this characteristic, we choose a vacuum cleaner B, which fulfill most or all the characteristic given. So we write back why we choose B, because it has small diameter of rod handle, it made from plastic hose, big fan, and high power of motor. All right. Okay, so this is the characteristic or the reason why we choose B. So student, how you are given mark in this part. So the first mark is coming from the first character. So this is the first mark. Second mark is the reason. Third mark when you choose plastic. Fourth mark when you give the reason. Fifth mark when you write big, size of pen big. And the reason it suck in more dust. Power of motor high, 7th mark. Why? Can rotate faster or can suck in more dust. And the 9th mark will be your right choice. Choose B. And the 10 mark will be the combination. Okay, you write back the characteristic for B as written here. So this is the format of answering question 10 or question 9 or question 10 in section B, which allocate 10 marks. Okay, so you don't have to write so long and you don't have to explain each characteristic. Just choose the best characteristic and give your reason for each. All right. Okay. Next. So that goes with the SPM format practice. Okay, for the next exercises, students, let us discuss the formative practice 2.3, which you can find in your textbook. Okay, so I believe you all have discussed this chapter in school, and I believe you have already conducted these exercises. So let us just revise it, okay, tonight. Okay, so now in the first question, you are given figure 2.21. So this is a manometer connected to a gas tank. Okay, it is containing water. Now we are using water inside the YouTube, and you can see this is the water level at this end connected to the gas tank, and this is the water level which exposed to the atmosphere. So from the diagram, we understand gas pressure is greater compared to atmospheric pressure because it pushed the water at the lower level. So we understand gas pressure is greater than atmospheric pressure, and the pressure difference is given as 36 centimeter. So this is represent H. All right. Okay, so first compare gas pressure in the flask with the atmospheric pressure. So I just give you the answer. So we understand gas pressure is higher than or greater than the atmospheric pressure. Okay, so you can write a gas pressure higher than, greater than, or use the symbol greater than the atmospheric pressure. 1 mark for that. Okay, then question B, state the difference between the gas pressure and atmospheric pressure in meter water. So this is the unit. So we are using water here. So the pressure difference is given 36 centimeters. So you just convert into meter. So it will be 0.36 meter water. Simple, student. Okay, then question C, you have to calculate the gas pressure in Pascal. Okay, so remember how to find the gas pressure in a unit Pascal. So you can refer to our previous exercises on the previous slide. Okay, so to calculate the gas pressure in Pascal, okay, so first, you must understand this is the given information. The density of water is 1000 kilogram per cubic meter, and the gravitational acceleration, G, 9.81, and this is the atmospheric pressure. Remember, 1 atmospheric pressure is also equal to 10.3 meter water. We learned this before, student, in 2.1. Okay, how we can represent atmospheric pressure. So 1 atm also equal to 10.3 meter water. So to find gas pressure in Pascal, so first we find the gas pressure in meter water. So 0.36, so we plus with 10.3. Okay, the gas pressure. So it will give you 10.66 meter water. Okay, so now we convert this into Pascal. Okay, so 10.66 multiply the density of water, multiply G, so it will give you 104,576.6, 74.6 Pascal. Okay, simple, right? Okay, then, okay, this is question 2, the second and third question. Okay, question 2. What are the advantages of using mercury manometer compared to a water manometer? So, any advantages you can think? What is the benefit or advantages of using mercury? So, this is similar to the previous question. So, this is all the advantages you may write. Number 1, mercury can measure higher pressure because it has higher density. Okay, it has higher density. Okay, second, that it does not need a very long tube compared to water. If you are using water, you need to use about 10.3 meter tube. Okay, so it is very difficult to move here and there. Compared to mercury, you need a shorter tube to apply. And third, you can write mercury has a rate of evaporation lower compared to rate of evaporation of water. Since mercury has a higher density, it also has a low rate of evaporation, meaning it does not easily evaporate compared to water because it has a high boiling point compared to water. Okay. Okay, if I'm not mistaken, the boiling point for mercury is 357 degrees Celsius compared to water 100 degrees Celsius. So next, you can write mercury is opaque. Okay, the color is opaque, thus easy to see or easy to read the level. Okay, and another point you can write mercury does not stick to the glass tube. Okay, mercury does not stick to the glass or it does not wet the glass tube, so easy for us to see the reading as well. All right, so this is advantages of using mercury compared to water inside a manometer. Okay, next. So I think this will be our last question for tonight. Question 3. Okay, you are given mercury manometer connected to a steel cylinder containing a compressed gas. Okay, and the pressure of the compressed gas and the atmospheric pressure are given 180 kilopascal and 101 kilopascal respectively. So 180 kilopascal goes to the gas pressure and 101 kilopascal is the atmospheric pressure. Okay, so you have to calculate the difference in height between the two mercury column in the manometer when given the density and gravitational acceleration as follows. All right. Okay. So how to find the difference in pressure? Very simple. 180 kilopascal. This is the gas pressure. 101 kilopascal. This is the atmospheric pressure. So the difference is 79 kilopascal, which is also equal to 79,000 pascal. Kilo means 1,000. 10 power of 3. So 79,000 pascal is the difference in pressure between compressed gas and atmospheric pressure. Okay, next. Okay, then difference in height of the two mercury column is given H. Okay, so this is what we are looking for. The difference in height of the two mercury column in a manometer is given as H. Okay, so how to find H? So from this formula, student, so H rho G, okay, this is the pressure of the gas in pascal, which is this 79,000. So we are looking for H here. So we just substitute the density given 13,600 and this is G 9.81 equal to 79,000 pascal. So by this we can find H by solving this mathematical equation. So H means 79,000 divided by these two, 13,600 multiply 981. So it will give you H 0.592 meter or in centimeter 59.2 centimeter. All right. So by this we have solved question 3. How to find the difference in height between the two mercury column in the manometer, which is 0.5 nanometer or 59.2 centimeter. All right. Okay. So as I mentioned to you all for the sharing, but before that, let me share with you the link for the e-sigil for our class tonight. So this is the link. You can fill up this link using any email domain. Okay, boleh gunakan sebarang email untuk isi link sijil pada malam ini. But make sure you fill up with correct information. So we can send the cert into your email in 3 working days. Okay, so anda boleh isi sijil kelas pada malam ini. Another thing, you can download and print out the module for tonight lesson in the pin from the pin messages. Okay, so you can download and print them out all for free. So you can use later when you came back to see this video, you can fill up all the exercises I discuss with you tonight. So anda boleh cetak keluar latihan ini secara percuma saja, lengkapkan semua latihan berpandukan video yang cikgu bincang lah pada malam ini. Dan ini adalah link sijil kehadiran. Anda boleh isikan dalam tempoh 30 minit selepas siaran kita tamat pada malam ini. Okay. So student, I guess that's all for tonight. Cikgu rasa itu saja perkongsian pada malam ini. So I hope you can understand this lesson and I hope you will try to do all the exercises I give you in the module, and by that I hope you to see you again in our next lesson. Jangan lupa bersama-sama kami lagi pada minggu hadapan, Panitia Fizik SPM di Akademi YouTuber. Minggu hadapan kita ada Cikgu Izian selaku presenter dengan tajuk dia 2.5 Momentum pada hari Jumaat 9.30 malam, dan pada hari Ahad kita ada kelas untuk tingkatan 5 pukul 8.45 malam akan disampaikan oleh Mr. Peh Kok Hua. Tajuk yang seterusnya 2.4 Pascal Principle. So please mark your calendar. Jangan lupa tandakan kalender. Jumaat 9.30 malam 2.5 Momentum, and then by Sunday 8:45 PM, Ahad 8.45 malam bersama presenter kita Mr. Peh. Tajuk dia 2.4 Pascal Principle. Okay, so itu saja untuk malam ini. Saya menyusun jari. Memohon ampun dan maaf sekiranya ada tersilap kata, tersasul bicara sepanjang cikgu menyampaikan kelas pada malam ini. Diharap kelas ini bermanfaatlah untuk semuanya yang menonton. Tadi saya mula dengan pantun, so malam ni saya nak tutuplah dengan pantun juga. Right? Okay. Dari Kedah ke Pekansari, beli swasta di kota tinggi. Selesai sudah kelas kita pada malam ini. InsyaAllah di lain masa bersua lagi. Jadi sekian dulu. Jumpa lagi dalam kelas-kelas fizik SPM yang seterusnya. Terima kasih di atas sokongan anda kepada semua guru fizik di Akademi YouTuber. Semoga kelas-kelas yang kami bawakan membawa manfaat kepada semua. Jadi Assalamualaikum dan jumpa lagi.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi YouTuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi YouTuber Malaysia, berpadu bersatu keluarga ayu, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi YouTuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha ayu, capai kecemerlangan, berpadu ayu, cipta kegemilangan, bersatu ayu, bina wadah terbilang, terus berjaya bersama ayu.
Berusaha ayu, capai kecemerlangan, berpadu ayu, cipta kegemilangan, bersatu ayu, bina wadah terbilang, terus berjaya bersama ayu.
Marah semua para ilmuwan, semai ilmu ke kepada anak wawasan tak kira di utara selatan. Sampaikan ilmu penuh kesungguhan. Akademi YouTuber Malaysia rangka laksana dengan jitu, penuh bervisi guru ayu mencapai misi yang satu. Bervisi kita bantu kita, bermoto sendiri yang kita biasa. Bersama kita luar biasa, berjasa demi nusa bangsa.